We know it's an isosceles triangle. We know that it has two congruent sides and two congruent angles. What would each of those have to be? Brett?
They have to be 45.
Good. Triangle sum. 180 minus 90 is 90. 90 divided evenly in half gets us that each of these is 45. 45. So this is the type of triangle we're looking at today, the 45, 45, 90 right triangle. All right, find the value of C using the Pythagorean theorem. What this means is that our final answer will have an x in it. We're not going to get like a number. So Pythagorean theorem is a squared plus b squared equals c squared. A and b would be our x's. C is obviously the hypotenuse, which is c. How do I solve that? I want to solve for C. Mira?
You add the two x's together, you get 2x plus
Good.
and then square root of both.
Good. So they want you to solve for C. That's the whole goal. Find the value of C. So for those of you that haven't taken Algebra 2 yet, next year when you take it, Chapter 1, you'll solve equations that have only variables in them. All variables, a couple numbers. If you haven't, this is a little bit new. If you want to solve for C, you want to use inverse operations to square root both sides. Normally we're solving for x, and that's why we divide by 2 first, but this one wants us to solve for C. So I'll be left with C. Now on the other side, I have the square root of 2x squared. What you can do is you can break this up into the square root of 2 times the square root of x squared. The square root of 2, we don't know what it is. Okay? It's not a whole number. But when you square root x squared, we would just get x. Usually we write that x root 2. So going back up to my triangle, get rid of the c. And make this x root 2. This is the formula for a 45, 45, 90 right triangle. X root 2. So if you know that this side is 7, this side will also be 7, and this will be 7 root 2. If you know this side is 10, this would be 10, this would be 10 root 2. So you only need to know one of the 3 sides, and you can figure out all the other ones without doing Pythagorean theorem if it is this special case. Okay. Tomorrow we'll learn the other special case, which is a 30, 60, 90. So in a 45, 45, 90, both legs will be congruent. And the length of the hypotenuse will be the square root of 2 times the length of a leg. You can use any variable you want. So if you prefer, you can label the legs x root 2, like we did in the formula triangle. Sometimes you'll see there are x's in the problem, so then it starts getting confusing, right? So you might want to use a different variable like s root 2, a root 2, b root 2. Doesn't matter what letter you use, but the legs have to be the same variable. The hypotenuse is that variable times the square root of 2. You have to memorize these formulas, whatever letter you want. I think I use s on most of my examples just because there are x's in our problems sometimes. So, find all of the missing side lengths. Some of these will be easier than others. Some of them you're going to have to do work with radicals, which we struggled on our last test. So we should notice that this is an isosceles right triangle, which means that these are 45 and 45. They don't have to tell you the angles. They just have to have the markings to know it's isosceles right, to know it is this case. So you want to label the formulas. So this would be s root 2. You don't have to, I know some of you already know the answer to this one without doing this, but some of them will be harder. And then they're only going to give you one side. So you're going to take the side they gave you and you're going to put an equal sign between the variable and the number. So s equals 5. Then all you have to do is take the 5 and plug it in around the sides. So this would be 5 centimeters. And this would be 5 root 2 centimeters. If they don't have variables, you can just write it on the picture. So 5 centimeters, 5 centimeters, 5 root 2 centimeters. Example 2 is the second case you could run into. And we have a 45, 45. So this would be S root 2. You cannot tell me that these sides are 6. So we know that 6 has to equal S root 2. So you create an equation with the number you're given and the formula that's on that side. Now you have to solve this for S. How would I solve this for S? Kel?
Square root 2 and then divide by 2.
You cannot square it. If you square both sides, you'll end up getting an S squared as well. Marquise?
Divide the square root of 2 by the side.
Good. We see multiplication. S times the square root of 2. The inverse is to divide by the square root of 2. Okay, I'm going to come down here. So we get S equals 6 divided by root 2. This looks like a bell ringer question from Monday. We are not allowed to leave that square root in the denominator. What do I do to move it to the numerator? Brett?
Rationalize.
Good. You need to rationalize the denominator. So we're going to multiply by whatever square root you see in the denominator. This is why I went over the radicals before we started chapter 7. So this will get me 6 root 2. Do not make it 12. Square root of 2 times the square root of 2 would be the square root of 4, which then is just 2. And lastly, we can divide those numbers to get 3 root 2. So S is 3 root 2. Once you get the value of S, we just take and plug it in. So if this is S, this is 3 root 2, and this is 3 root 2. So this is the harder case, obviously. All right, the next one, we see that this has been flipped around. Again, remember that the S's go on the legs. The S root 2 will go on the hypotenuse. So in this case, they actually tell me what S is. You create an equation with the variable and the number they give you. So this would be S equals 21 root 6. This is the easier case. You don't have to solve for S, it's solved for. S is 21 square root of 6. So all you have to do is now plug that in, whoops, for S in both parts. So this leg would also be 21 root 6 miles, excuse me. Now the hypotenuse, be careful, you're plugging that in for the value of S. So this would be 21 root 6, and then we have to bring down that times the square root of 2. Okay, when you're multiplying, you would multiply those square roots together to get 21 root 12. And then we have to reduce the square root of 12 into what? Marquise? 4 and 3. Bring down the 21 with it. Take the square root of 4, which is 2. Now we multiply our outside numbers together to get 42 root 3. So this side would be 42 root 3 miles. Okay, next one, label your triangle S squared of 2 or X squared of 2, whatever you like. So we need to create an equation setting s root 2 equal to 16 root 10. And then we'll solve for s. So there's two scenarios. They can either give you the leg and you just plug in s, or they can give you the hypotenuse and you have to actually solve for s and then plug it in. So same thing that Marquise told us before, we would undo multiplication with division. Now I always stack my square roots underneath each other because those are the like terms in this equation. So 16 would just stay 16. The square root of 10 divided by the square root of 2, I would just divide those because they're divisible. If they weren't, then you'd have to rationalize. We'll just get the square root of 5. Take that and plug it in anywhere we wrote s, so this would be 16 square root 5 feet, and this would be 16 square root 5 feet. Okay, on the back we'll make it a little bit harder. We're going to have some complex shapes and some same word problem we've done like every day. Diagonal television, diagonal of a walkway. Say we have diagonal of a playground. What shape is number 5? It's a quadrilateral, but I think we could say more than just quadrilateral for this one. You might want to look at it sideways.
Trapezoid.
It's a trapezoid. Very good. Since these are both 90, that would indicate that these are parallel using the converse of the same side interior angles theorem. This would be a trapezoid. That's kind of irrelevant. I'm just reviewing previous vocabulary. Now, at this point, I don't see a triangle. But you can always draw in what's called an auxiliary line. You can draw in any lines that you want to split shapes into other shapes that we may know. So you can draw in a line right here to create now a rectangle and a triangle. So from here to here is 6, which means from here to here is 6. The 10 is about this whole length. So we can use the segment addition postulate in reverse. 10 minus 6 would tell me that this little piece is 4. Now we have two variables in this case. We have x and we have y. Now when I drew this segment in, I did make it perpendicular, so I'm creating a right triangle. A 45, 45, 90 right triangle. So the formula for our 45, 45, 90 is s root 2. You don't have to write the formulas if you're understanding this. You can just go 4, 4, 4 root 2. But some students need it still. So that means s is 4. So if this is 4, this is also 4. This would then be 4 root 2. So x equals 4 root 2. There's no units to tack on here. And since this value is 4, this also has to be 4, because those would be congruent. It's a rectangle. So y would be 4. All right, now number 6 is the same type of problem. The only thing that makes it harder is the square root on the side. So we have a 45, 45, 90, so we'd have our s root 2. Make sure the s root 2 goes on the hypotenuse, the longest side. So they do tell us what s is. So that's easy. Fill it in. If this is 2 root 2, that's just 2 root 2. Now be careful when you plug this in for s that you don't forget to attach another root 2. This is s root 2. So this would be 2 root 2, which is your s value, times another square root of 2. What would I get when I simplify that? Maddie? 4. The square root of 2 times the square root of 2 is the square root of 4. This other 2 just comes down. The square root of 4 is 2. 2 times 2 will get you 4. So x is 4. Alright, now the only reason I put this walkway problem on here again, I wish I would have picked a different number besides 24, but I didn't. We did the same problem yesterday, and you did the same problem the day before in the homework. But I'm going to show you today that you can do it a different way. So we know that a square playground has 4 congruent sides. The walkway is diagonal, 24 meters long. So in yesterday's lesson, I put x, and I did Pythagorean theorem. X squared plus x squared equals 24 squared. You can do it that way. However, a square, if you draw in a diagonal, will create 45, 45, 90 right triangles. So an alternative method to yesterday's lesson is that we could use our right triangles, s root 2. A lot of students prefer the Pythagorean theorem over this, but for all the problems that we've done so far, you would not be able to do the Pythagorean theorem. You would have to use a special right triangle. This one, you would have the option of choosing. So at that point, I would then say s root 2 equals 24. Solve for s. Undo multiplication with division. Can I divide those and just say 12? No, absolutely not. We have to rationalize. Multiply by the square root of 2 in the numerator and the denominator. So we have 24 root 2 all over the square root of 2 times the square root of 2, square root of 4, which is just 2. Then we can divide those numbers to get 12 root 2. Same answer we got yesterday, if you remember. They also want us to find the area. I'm going to skip that. We did that yesterday. But we would just take s squared. We end up getting 288 square meters. All right, the last one, this comes up somewhere. I don't remember if it's a partner challenge, if it's a quiz, study guide, something, but you'll see this again later. And I do remember students saying, we never did one like this. Here it is in your notes. Find the perimeter of the figure and round your answer to the nearest hundredth. So we're finding the perimeter of the outside. So obviously, to find the perimeter, we would take 17 plus 17 plus something. How would I find the distance around this half circle? The distance around the half circle. Right.
It would be half of the circumference of the circle.
Perfect. It would be half the circumference of the circle. Which we learned back in chapter 1. Who remembers what the circumference formulas are? There's 2 of them. Alright? Yes, one is pi d. The other is, Justin? No, that's area. Brett? 2 pi r. And that's because 2 times r is the diameter. Okay? You learned those back in chapter 1. If you go back to your notes, section 1.9, I want to believe, is I remember correctly. Now, if you want to find half of the circumference, you just have to multiply the diameter, or excuse me, pi d times 1/2, or divide by 2 at the end of it. So, obviously here we get 34, plus, now to do half the circumference, I'm going to do 1/2, and I might use the pi d formula. Because if you notice, we're going to have the diameter once we get there. How long is the diameter going to be? 17, not 17, 17 root 2. So since these are congruent, that means this is an isosceles right triangle, which means these are 45, 45. So this would be s square root of 2. So the whole thing is 17 root 2. That's your diameter. So, they do tell us to use 3.14 or the pi key in our calculator, and the diameter will be 17 root 2. So we are going to round this to the nearest hundredth, which is 2 decimal places at the end of the problem. So I will type this whole thing in my calculator. Shrink down on my. So we'll have 0.5 times, I'll use the pi key, times 17 root 2. You can type it all in. 0.5 times pi times 17 root 2. Hit enter, and we'll get 37.76. If you use 3.14, you may get a different number if you don't use the pi key. It might round slightly differently.
I might get a different number.
Uh-oh. Did you take half of it yet?
Yeah, 8.5.
Oh, I didn't add 34 yet. You put the 34 in. So now I'll add 34 to that, and then I'll get the answer you got. You just type that whole thing in, which is fine. You can do that. And that will be centimeters or centimeters squared? Just centimeters. Perfect. All right. The closure says to add this to your right triangle cheat sheet. I'm going to give you that tomorrow. I didn't have it copied yet. You'll get a little, and by cheat sheet, I really want to say study sheet because you don't get to use it on a test. But it's going to be something that you can study. Study purposes only, not permitted during quizzes or tests. Let me pass out your homework.